next speaker today is Lachlan McEwen, and he's going to be talking today about efficiency and sustainability by design. So Lachie is a design practitioner of many years of experience in the industry and, again, passionate advocate. At the helm of his own business, he seeks to encourage his clients to understand the full potential of their future home as a vessel of positive living. So he'll be talking to you today, and what he can talk about is ranging from passive solar solutions, case studies, energy modelling, through to full net zero potential and energy literacy. Welcome to Lachie.
Then is a hard act to follow. Energy efficiency is one pillar of sustainability. Topics of discussion are going to be about defining energy, looking at energy literacy, why that's important, net zero potential. I've sort of coined this term myself, but I understand there's other people out there using it, and you'll understand why. Energy modelling in housing, why we do that, what it is. A demonstration of energy minimisation via net zero design competition that I've been directly involved with. So we'll be looking at a 10-star NatHERS rated passive solar living model that accounts for its full carbon footprint. Really, the focus of this presentation is about embodied energy and consumption, and that's one pillar of the IPCC's sustainability development goals. But of course, there are other things within the IPCC's declaration of these goals, which include net zero carbon, which is both embodied and consumption of energy, triple bottom line accounting, recognising the equality between economic, social and environmental values, diversity, collaboration, urgency, leadership, education and accountability. So that's the big picture of sustainability. This is focusing on energy, this discussion. Energy literacy, what is it and why is it important? To me, it's what I think of as motivation. What's our motivation? So we've heard from Ken that there's a lot of fantastic motivation to look at sustainability, and this is another set of reasons. So the renewable energy revolution is transforming all industry at high speed. Australia is lagging due to previous policy vacuums, but we're a bunch of smart cookies, aren't we? With an appetite for competition. So it's really very simple. Renewables are the economically viable replacement for all power generation sources. And at a domestic level, on-site power generation and storage will drive all future technological machinery due to economic advantage and stability and convenience. So putting a price on carbon will drive action for many industrial activities, but it's reasonably evident that we're already paying an increasing cost for fossil fuels, and that's even prior to subsidies for fossil fuels being scrapped, right? With energy costs increasing, we're all looking for ways to become self-reliant. If you don't already know what you pay for a kilowatt of electricity, don't worry, you soon will. It's all hitting us in the hip pocket. I think it's a good thing that we're going to be forced to become literate in the language of electricity. Simply understanding what units of power are worth to buy and sell, and how much we're consuming or producing, this will become second nature. Once we're all speaking the language fluently, that will indicate a nation which has transitioned into a fully electrified economy where consumers truly hold the balance of power. Solar power is a bit like a knight in shining armour who's riding in on horseback to save us from the perils of market forces and grid instability. Soon it will become common language to discuss kilowatt hours per 100 kilometres instead of litres of petrol. And we'll know how many sun hours we need to effectively run our lives. Fossil fuel-based equipment will be consigned to the scrap heap along with the economic structures that have been keeping them alive. So for the purpose of this discussion, we're talking in terms of energy consumption within buildings. Terms like megajoules and kilowatts are units of measurement by which we measure, buy and sell power. Watts, or in fact kilowatt hours, typically describe power, electrical power. These are terms you see on your electricity bill, for example, reasonably obvious. Megajoules is a unit more aligned with gas appliances. However, critically, it is another unit of measurement, and it's the metric which is used for the Nationwide Housing Energy Rating Scheme, or NatHERS as people know it. And That's to determine a home's energy usage. So to determine a home's energy usage, NatHERS describes this system of megajoules per metre squared per year, and the scheme provides a star rating based on how efficient that is said to be. So on the right-hand side, we can see the star rating scheme. Some of you might be familiar with that. This is from a house that I undertook on Kangaroo Island. It's quite a small footprint house and also achieved a very, very high star rating. And you can see there that on the megajoules is highlighted there, where I've got the red arrow pointing to that. And underneath, there's a combination of heating and cooling combined that make up that total amount. Existing homes can also be measured by the residential efficiency scorecard, and that's something else to look at if you're renovating. So there's improvements in the pipeline. The National Construction Code NCC 2022, which has come out this year, requires a minimum 7-star rating, which is an increase of 1 star over the previous minimum 6-star rating. We'll talk about that a bit more later. But importantly, it's also bringing in new whole of home ratings, which consider fixed appliances, so the bigger picture. And that's a step in the right direction because it's bringing about accountability, or whole accountability, as it's called, whole of home accountability. And that sort of sets up for what is really a truly net zero potential, understanding true net zero potential. Obviously, we're familiar with these sorts of ratings. That's something that we're going to be looking at much more closely when energy raters get involved with looking at a new project, because they need to understand whole of home, and they need to write about they need to measure whole of home by looking at the efficiency of the fixed appliances and what energy they consume, and then building that into the bigger picture of the certificate. And if I just flick back quickly, you'll see a highlighted square down the bottom. That's the new certificate, and how that's going to look in terms of combining not only just the consumption, but also the fixed appliance consumption down the bottom. And that's an addition that's coming to the market, which is fantastic, I think. So just quickly looking at net zero potential, what is it? I am explaining this because previously I thought it's a bit wishy-washy, but I think it's quite real. All activity, including construction and occupations of buildings, needs to be understood in terms of net zero potential. This is to say that net zero is a concept which is given credibility by the idea that there's a carbon debt to be paid and the potential to repay that debt. What is it? When understood from a level of serious action on climate change, net zero potential should almost be given a star rating system of its own, I think, because the ability of humanity to repay our cumulative carbon debt within a limited time frame of, say, 15 to 25 years is what we're talking about, is the most fundamental measurement we're working towards if we're going to maintain global temperature increases below 1.5 degrees. Because taking longer, and that's because taking longer than 25 years to reach net zero from this point forward will massively compromise the potential for us to remain below that 1.5 degree temperature increase. As you'll see later on in this design study, even a highly efficient home will take 15 to 20 years to repay that debt. I'd encourage you to read this book, this quarterly essay from Alan Finkel, Getting to Zero. The poor guy had to work under the auspices of Tony Abbott's, so without going into politics, I think it's probably worth forgiving him for ever appearing to be conservative about the power revolution. If you read his book, he's anything but. It's a bit dry, but it discusses the potential and necessity of pivoting towards new power at a domestic and industrial level. What contributes to unnecessary energy consumption? Heat constantly transfers energy, resulting in heat gains or heat losses. The speed at which heat transfers occurs via low thermal resistance of the building envelope and thermal bridging, predominantly through the air and through surfaces. Higher energy consumption is a result of an inefficient building envelope, and materials and methods which resist heat transfer through the walls, roof and floor are most efficient in slowing the pace of heat transfer. So installing products with high R values or low U values will slow the flow. Reduced consumption can be achieved through orientation to take advantage of free passive solar heat gains, blocking out unwanted heat gains, building with highly insulative low embodied carbon materials, identifying air leakage and unnecessary heat transfer in locations around your building envelope, that should say, smart systems monitoring usage of existing and new equipment, as well as on-site generation and consumption at a place of use. So what I'll do quickly is speed up to the presentation. Actually, I have one key thing which I did want to discuss with you before I jump to a video. What I will just say briefly is that we do have tools to understand this. It's very important that when we're procuring new buildings as clients, that we work not only to a concept, but to following that concept through. So as-built verification is something which is coming to be better understood in the market, whilst there are models for that exist, such as Passive House, and that is almost like a contractual obligation by using Passive House and employing a builder that works to that method. We can do similar things by just working to our own determination to ensure we verify what has been specified. And you can refer to this, the Sustainability Victoria, and there's other places you'll find that information as well. So I won't go into talking about this because I'm running out of time, but an example to consider how low energy consuming buildings can save you money is on screen with regards to a colleague's job that I was discussing the other day. You can see there that after development, they're looking at a power consumption around their home of a quarter of the price that they would have been paying before, or slightly less than a quarter. I just wanted to ask at this juncture, I've got a door prize, which is a bottle of wine for anyone who can answer this question. And you can come and see me afterwards to grab that if you can answer the question. If not, no one gets the wine. But the question is this. And it's not for people who already might drive an EV. If you don't drive an EV, you're allowed to ask this question. But based on the average electricity cost of, I'll go back. If anyone can tell me what the cost to fill up a mid-size EV tank with electricity is, they can win this bottle of wine. Does anyone know the answer to that question?
Less than $10.
Close. What's that based upon? Oh, okay, good. You're excluded. You probably got a small SUV, but all right, we can discuss the principles of this wine for sale later. Come and see me at the desk out the back later. Point being, I think it is my answer to that question is based on the average electricity cost of say 30 cents. An EV with a commonly sized 78 kilowatt battery, which are common in the market, will cost you about $23, so twice as much as what your EV might cost for a full tank of petrol. Or it's free if you've got your own solar panels and energy being generated from your solar. Given that I have to wrap this up, I'm going to play a short video.
Hi, I'm Lachie from Harmonic Design.
And I'm Melanie from Sustainability Certified.
And we'd like to tell you about our true zero carbon design. Our project is based in Sydney, where we've achieved a full 10-star NatHERS rating with a predicted heating and cooling cost of just $42 per year. We've calculated that both the embodied carbon and operational emissions of our design will be completely offset by on-site solar power by January 2040. Our intent for the True Zero Carbon Challenge has been to create a sense of aspiration towards thermal comfort and energy efficiency in a home that's uncompromised by aesthetics or living standards. Our strategy of sustainability by stealth has been our mantra. We've sought to inspire mass appeal within the housing sector by demonstrating how easily we can all level up. This also inspired the name True Blue Zero CO2, because the design intentionally relies upon conventional building materials and common construction practices. With our combined expertise and via a robustly detailed composition, we've forged a design which is easily buildable and truly obtainable for the masses.
To reach our 10-star NatHERS rating, we based our project around the core principles of passive solar design, and using the First Rate 5 modelling software, we kept working through multiple iterations to fine-tune the design. The home includes thermal mass via the ground-coupled concrete slab, a well-insulated building envelope with R4 batts in the walls, R6 in the ceiling, and a layer of DuraPanel to all external walls and roof, timber frame double glazed windows, eaves designed to capture winter sun and block summer sun, natural cross ventilation, adjustable vertical and horizontal shading for outdoor living spaces and to reduce summer heat load, and a well-sealed envelope.
Throughout the home, we've specified a palette of materials that are inherently lower in carbon, often with an organic base, ranging from products like metal cladding that are simply efficient through to some innovative and less conventional ones. Each material has a discrete application and relatively minimal embodied carbon. These choices include DuraPanel, a carbon sequestering compressed straw substrate made in Victoria, fixed directly to the structure, zero carbon concrete, James Hardie low embodied energy cladding, WeatherTex cladding, timber windows, eco-friendly fiberglass insulation, reclaimed bricks, bamboo and paper rock joinery.
Our design is all electric with highly efficient split system air conditioning, heat pump hot water, water efficient taps, showers and toilets, and a 22,000 litre rainwater tank. We chose Australian made solar panels for our 14.5 kilowatt system.
Our dynamic design ticks a lot of boxes. It has an interior filled with natural light and fresh air, and that's connected to abundant gardens, working to new livable housing standards with functional spaces that allow aging in place and working from home, and a relatively compact design that is affordable to build and maintain, and most importantly, intergenerational equity due to being truly net zero by 2040.
Both Lachie and I have thoroughly enjoyed our involvement in the competition. It has presented a rare opportunity for us to work together from the inception of a project to develop a collaborative design. Too often it feels like building designers and thermal performance assessors are on opposing sides, but when we work together from the early design stage, the process becomes less about the TPA needing to fix a poor design to achieve minimum compliance, and instead we have the opportunity to produce designs of 8, 9 and even 10 stars. Working through the complex embodied carbon calculations, whilst challenging at times, was an excellent learning experience and highlighted how important this process is right now in our industry if we are to reach net zero. We would both like to thank Jeremy Spencer, Vicky Marshall and the Design Matters team for putting together this innovative competition, and we look forward to competing again next year.
Thanks for listening. Hopefully you've all got an improved understanding of how to obtain energy efficiency, as well as the motivations that are driving the need for improved efficiencies, as well as how to reach full net zero potential. Thank you.